Assalamu alaikum.
Alaikum assalam, sir.
Okay, so any doubt from last chapter, that is kinetic theory of gas? Okay, let's start with new chapter, that is oscillation. To define this, let me explain you some basic term related to this part. First is periodic motion. Hiba, do you have any idea what do you mean by periodic motion? Suppose motion of planet around the sun in elliptical orbit, motion of electron around nucleus in circular orbit, motion of pendulum or motion of bob about given axis. Let's say this is axis and a bob attached with a string is going to and fro along this path. So these all are periodic motion. So we may define periodic motion as the motion of a body having fixed time period. Suppose I'm defining for Earth. So it will take on one complete rotation, revolution around the sun, 365.25 days. And it will be constant for Earth. Similarly, for electron, on complete rotation around nucleus in first orbit, it will take about 1.5 10⁻⁻16 seconds. And in case of Bob, on going from one part to another and comes back, it will take about 2 seconds. Only in case of second pendulum. So in all these different motion, we can call these all have some fixed time period for its motion about its own path. So we may define periodic motion as the motion of a body having fixed time period is called periodic motion. Now there is some special property of periodic motion in this part in case of simple pendulum other than these two terms. In this simple pendulum, it is oscillating to and fro about a given fixed point. This given fixed point is called mean position. This one end is called extreme position. And also this other end will be extreme position. So we can say in this part, it is motion about a given fixed point, that is mean position. So we can call this particular periodic a spatial term, that is simple harmonic motion. So we may define it as a periodic motion in which body moves to or fro or up and down about a given fixed position called mean position. Then motion of body is termed as simple harmonic motion. Is it clear?
Yes, sir.
Yes, sir.
So we may define a periodic motion in which body moves to and fro or up and down about given fixed position called mean position, then it is called simple harmonic motion. So from this we can say it is a special type of periodic motion. So all SHMs must be periodic, but all periodic must not be SHM. So from this part we can say all SHMs are periodic, but all periodic are not SHM. Hamza, any doubt?
No, sir.
Just write it down. Hamza, done?
Almost, sir.
Okay.
Done, sir.
Now to define this particular simple harmonic motion or its motion to and fro or up and down, let me give you an example. Uniform circular motion as simple harmonic motion or SHM. Suppose a body is moving along circular path at constant velocity or angular velocity omega. This is one of the diametrical axis, that is y-axis. Suppose a particle is initially at this point. Further on moving, it may reach to this point, further to this, Okay, in this part, a particle is going along uniform circular motion with constant uniform angular velocity omega. So if you take its projection along x-axis, so particle or projection of particle will be at this point. For this part, it will be at this point, and this point. It means particle from this point will tend to move along this way to reach at this point. And further, if we define projection for this particle, it will act to move backward this point. So from this, we can say this is nothing but motion of projection of particle along x-axis, and it is behaving to and fro motion about origin. Hamza, is it clear?
Yes, sir.
So we can say this is nothing but motion of projection of particle along x-axis. Now suppose if you have to calculate for y-axis, for this particle, projection will be initially at this point. So if we define this motion, it is behaving to go upward from this point to this point to reach maximum, then comes back to this point and further along this direction, and then return back to origin. So this is nothing but motion of projection of particle along y-axis, and is behaving to move up and down, up and down, up and down about given fixed position, that is origin here, which is behaving as mean position. So we can say this is motion of projection of particle along y-axis. So on concluding these two parts, we can say during uniform circular motion of a body along circular path, the motion of projection along any diametrical axis, that is along x-axis or y-axis, it will behave as simple harmonic motion. Hamza, is it clear?
Yes, sir.
So we can say during uniform circular motion, the motion of projection of particle along any diametrical axis is simple harmonic motion. Khalid, Is it clear?
Yes, sir.
Okay, just write it down. Hamza, done?
Yes, sir. Done.
Okay. Now, using this concept of uniform circular motion, let me define you how to calculate equation of simple harmonic motion. So next is equation of simple harmonic motion. Suppose particle is moving along circular path at constant angular velocity omega. Let's say particle is initially at this point at time t is equals to 0. Further, due to its rotation, it may reach to this point at some time t. So if we define its projection, let's say this for this particular part, at time t is equals to 0, this particle or this particular line may have some inclination with respect to x-axis. Let's say this is called phi. On rotation from this point to this point, at constant angular velocity, angle described from this point to this point will be omega times t. So total inclination of this point will be omega t plus phi. Now let me define you. Consider a body having mass m is moving uniformly along circular path of radius A at velocity omega, that is angular velocity omega. So for this part, let's say this projection I've just taken vertical projection from this point to this point. So for this part, this will be horizontal projection along x-axis, and this will be its vertical projection along y-axis. So this will be x, and this will be y. The radius of this particular circular path is a. So this term will be a. Total inclination will be theta. So theta is equals to omega t plus phi in this part. Hamza, any doubt up to this?
No, sir.
Now, from triangle, sine theta is equals to perpendicular over hypotenuse. So y will be equals to a times sine theta, and theta we have omega t plus phi. Similarly, cos theta is equals to base over hypotenuse. So x will be equals to a times cos theta is omega t plus phi. So we have two different parts. One is y is equals to a times sine omega t to define its vertical projection or projection along y-axis. And this is x is equals to a times cos omega t, that is projection along x-axis. So these two equation is called equation of SHM. Now let me define you different term in this part. First, x and y in this part is defining you nothing but displacement of particle at any time t. A is maximum displacement, which is also called amplitude related to this particular equation of SHM. Next is omega. This is angular velocity. We may calculate time period and frequency from this part according to expression. Omega is equals to 2 pi by t, or simply 2 pi into frequency. Or you will say frequency and time period will be reciprocal of one another. And one more part, that is theta, which is equals to omega t plus phi. On knowing the value of theta, you may define curve at different instant, or it will simply define you nothing but phase. So this theta is called phase at any instant. So let's say at t is equals to 0, theta will be equals to phi. This is also called initial phase. Just write it down up to this part first.
Sir, omega t plus, what is it that called?
Phi.
Okay.
Hamza, done?
Yes, sir. Done.
Now let me give you a question related to this part and how to solve it. If 10 by is equals to 5 times sine pi 10 times t plus 1 by 6. So from this part, find first amplitude, second frequency, time period, initial phase, phase at 0.2 seconds, displacement at 1.5 seconds. Let me define you how to solve. We have this equation. So first, this is not in standard form. So we have to write this particular equation in a standard form. In this part, we have 10 times y. So first, move this 10 to right side. And we have pi outside of this bracket. So move this pi inside of it. So you may write it like this. Y equals to 5 by 10, that is 0.5. Sine, move this pi inside of bracket. So you will get 10 pi t. And on multiplying with this part, you will get pi by 6. Now it is a standard form. Now just compare this equation with the previous part. So you will say coefficient of sine or cos will be amplitude. Coefficient of t will be omega. And single constant term in this phase will be initial phase. Hiba, any doubt?
No, sir.
So from this part, we can say amplitude will be 0.5 meter. Omega is 10 pi. Omega is equals to 2 pi f. So frequency will be 5 hertz. Third, we have to calculate time period, which is reciprocal of frequency. So it will be 1 by 5, that is 0.2 seconds. In fourth part, we have to calculate initial phase. Initial phase is phase at t is equals to 0. In this part, this term will define you initial phase. So phi will be pi by 6. Next, we have to calculate phase at 0.2 second. So what do you mean by phase? It's just theta, which is equals to omega t plus phi, this entire term. Now, omega we have 10 pi t 0.2 seconds plus phi pi by 6. So this will be 0.2 into 10, that is 2 pi plus pi by 6. So 6 into 2, 12 plus 1, 13. So it will be 13 pi by 6. That is phase at 0.2 seconds. Khalid, is it clear?
Yes, sir.
In last part, we have to calculate displacement at time 1.5 second. So according to the formula, y is equals to 0.5 times sine 10 pi. In place of time, we have 1.5 seconds. So it will be 1.5 plus pi by 6. Now just simplify it. So you'll get 0.5 sine 10 pi into 1.5. So it will be 15 pi plus pi by 6. Now there is identity related to this part. Sine of pi plus theta is equals to minus of sine theta. Since this particular term would lie in third quadrant where sine theta will be negative. So using this property, we may write it like minus of 0.5 into sine pi by 6. Hiba, just tell me the value of sine of pi by 6. Pi is 180 degree divided by 6, so it will be 30 degree. It means sine of 30 degree. What will be the value of sine of 30 degree?
So 1 by 2.
Good. So it will become 0.5 divided by 2. That is 0.25, and negative sign would be displacement at this instant. Salman, is it clear?
Yes, sir, it's clear.
Good. Just write it down. You all have done? Hiba, done?
Yes.
Okay. This is how to calculate displacement, amplitude, time period, frequency related to the any equation related to SHM. Next, you will be asked, what will be the condition of an equation to be SHM? Let me define you. Suppose y is equals to a times sine omega t. So if you differentiate this particular part, on differentiating with respect to time, dy over dt, y is displacement and we are differentiating with respect to time, so it will define you velocity. In this part we have two different terms. One is this particular sine and the next is omega t. A is constant, so keep it outside. So first differentiate this particular sine, so its differentiation will be cos of omega t. Next, differentiation of omega t, in which omega being constant, keep it outside, and differentiation of t having exponential 1. So according to the formula, n x n minus 1. So it will become just 1. That is, differentiation of t will be 1. So you will get velocity of body in SHM will be omega times a cos of omega t. Now again, if you further differentiate it, on differentiating with respect to time, again, you will get dy over dt, omega and a being constant, keep it outside. Differentiation of cos will be minus of sine omega t. Next function we have omega times t, in which omega being constant, keep it outside, and differentiation of t will be just 1. Now in this part, dv over dt will be acceleration is equals to minus of omega squared a times sine omega t. This entire term a times sine omega t is nothing but displacement. So we may write it as acceleration is minus of omega square phi. Khalid, any doubt?
No, sir.
In this part, you will be asked to define the general differential equation of SHM. Next, what will be the condition of SHM? So from this part, we can say acceleration of particle is directly proportional to displacement, but with negative sign. So for any different equation, if you have just arrived for this part, it will be SHM. Otherwise, it will not be SHM. So we may call this particular part to be condition of SHM. So this is condition of SHM. So how to prove a function is performing SHM or not? Just differentiate it twice. And if you get this particular expression, then you will say it must be. SHM. Salman, is it clear?
Yes, sir, it's clear.
Next, as velocity is dy over dt, so we may write acceleration as dv over dt. So it will be d over dt of velocity, which is nothing but dy dt. D and d will become d2y, and dt and dt will become dt squared is equals to a. So this is called double differentiation of displacement with respect to time to get acceleration. Now using this concept, you may write acceleration, or in place of acceleration, d2y over dt squared. Move this omega square y to left side. So you'll get plus of omega square y equals to 0. This expression is called general differential equation of SHM. So you will be asked to derive general differential equation of SHM. So what will you do? Just start from this part, differentiate it to this point, convert this acceleration in terms of this. So this expression may transformed into this part. So this expression is called general differential equation of SHM. Hamza, is it clear?
Yes, sir.
Okay, just write it down. Hamza, done?
Yes, sir. Done.
Okay. Now next problem will be to calculate phase difference between these three different terms. So to define phase difference, let me give you some formula in relation to it. First, if you have to convert cos theta in terms of sine, here we have plus sign. So it will be just sine theta plus pi by 2. But if you have minus of cos theta, you may write it as sine theta minus pi by 2. Next, if you have sine theta with negative sign, so you may write it as sine of theta plus pi or sine pi plus theta. In this entire term, all we have to convert the rest of the whole thing into plus of sine theta term. So you may use this different formula to convert from one part to another. Let me define you. As for displacement, we had y equals to a times sine omega t. So this omega t is called phase for this part. If we have function sine. Now, for velocity, v is equals to omega times a cos omega times t. So first we have to convert this particular cos in terms of sine to find phase. So how to calculate this cos into sine? So we have plus cos theta in this part. So according to this first rule, we may write it as omega times cos omega times a cos theta is equals to sine theta plus pi by 2. Now, in this part, we have function sine and phase attached with that part, attached with this part is omega t plus pi by 2. Now for acceleration, a is equals to minus of omega square a times sine omega t. In this part, we have sine term with negative sign. So first we have to convert this negative sign into positive. So using this third equation, we may write it as omega square a sine omega t plus just pi. Now we have all different function in sine and phase related to those function are this. So you'll be asked, what would be the phase difference between velocity and displacement? Just compare these two parts. What is the difference between these two angles? Hiba? Is there any difference between this part and this part? Hamza? Is there any difference between this angle and this angle?
Yes, sir.
By how much?
Sir, by half.
By pi by 2. Okay.
Yes, sir, by pi.
So we can say displacement and velocity differ in phase by pi by 2. What you can say about this particular acceleration, this having omega t plus pi. So if you have to compare with displacement, so you'll say phase difference between displacement and acceleration is pi. Is it clear?
Yes, sir.
So we may write phase difference. Just 1 minute. This is displacement, velocity, and acceleration. So in between these two parts, phase difference is pi by 2. In between these two parts, phase difference is pi by 2. And in between this and this, phase difference is pi. So just remember it. Khalid, any doubt?
No, sir.
The next thing we can define from this part, graph related to these three different terms. that is displacement, velocity, and acceleration. Let me just draw it. In case of displacement, we have sine function. So its curve will be like this. 0 to maximum, then 0, minimum, then again 0 to this point. So this is one complete wave related to this part. For velocity, which is cosine function, it means at t will be 0, cost will be maximum. So it will start from this part. Move to 0. Then negative side, positive, and then to same point. And last part for acceleration, which is minus of sine of omega t. So it will be towards negative side. This part. So this is displacement versus time. This is velocity versus time. And this is acceleration versus time. From this part, we may define for a different position, which term will be maximum. Suppose this first point, mean position. So at mean position, displacement is minimum, but velocity is maximum and acceleration is also minimum. But this is extreme position. Acceleration is maximum, velocity is minimum, and displacement is also maximum. So we may define different term or its maximum or minimum with respect to its mean or extreme at different point from this particular graph. Khalid, is it clear?
Yes, sir.
Just draw this. Hamza, done?
I'm making the graph.
Okay.
Done, sir.
Khalid, any doubt?
No, sir.
Now, next question up to the in this part will be to find maximum and minimum value related to displacement, velocity, and acceleration. So let me define you how to solve. First, we have displacement. Y is equals to A times sine omega t. Next, velocity. V is equals to omega times A cos omega t. You may write this particular expression as omega times A root under 1 minus sine square omega t. I'm using here sine square theta plus cos square theta is equals to 1. So cos square theta will be equals to 1 minus sine square theta. So cos theta will be equals to root under 1 minus sine square theta. I'm just using this part. So from this we can say cos theta is 1 minus sine square theta root under. Now move this A into inside of this particular root. So it will become A square. So on multiplying with first part 1, it will be A square, and with second part sine square omega t, it will become sine omega t whole square. Now this expression A times sine omega t is nothing but y. So we may write it as omega times root under A square minus y square is equals to velocity. Hiba, any doubt?
No, sir.
Next is acceleration. As acceleration is minus of omega square A sine of omega t. A times sine omega t is y, so it will be minus of omega square y is equals to A. Now we have just derived velocity and acceleration in terms of displacement. So from this part, we can say first, at mean position, displacement will be minimum. So for mean position, when y is minimum, velocity of body will be maximum omega times a. In terms of acceleration, for mean position, acceleration will be 0 since y is 0. Next, extreme position, when displacement is maximum. So if you substitute in this part for extreme position, velocity will be minimum, that is 0. And also in this part, for extreme position, a will be maximum, but in opposite direction, minus of omega square a. Hamza, is it clear? Okay, just write it down. So from this part, we have just defined maximum value of velocity, displacement, and acceleration. Hiba, done?
Yes, sir.
Suppose we have y is equals to 0.4 sine pi times t. Find first maximum velocity, second displacement at 1/6 of a second, third acceleration at 1/6 of a second. Try to find just compare this equation to the previous part. Apply the formula and try to solve. Khalid, any problem while solving?
No, sir. Not now.
Okay. Tell me the first answer. Hiba. Tell me the value of amplitude from this expression. Salman, tell me the amplitude of this expression.
0.4.
What would be the amplitude?
0.4.
Okay. Omega.
0.4, right, sir? Sir,
Yeah.
can you hear me? Yeah, okay.
Omega is
Theta. No, sorry, pi. Pi.
okay. Hamza, just tell me the formula of velocity maximum.
Omega into amplitude.
Good. Omega is 3.14 multiplied by 0.4. So you'll get 1256 with 3 decimal. That will be 1.256 meter per second. Next, we have to calculate displacement at 1/6 of a second. So according to the formula, y is equals to 0.4 times sine pi, and t we have 1/6 of a second. So it will become 0.4 sine pi by 6. It means sine of 30 degree. Khalid, just tell me the value of sine 30 degree. Hamza, sine 30 degree is equals to?
The 1/2.
Good. So it will become 0.02 meter. Now in last part, we have to calculate acceleration at 1/6 of a second. So according to the formula, acceleration is minus of omega squared times y. Since we have omega and y in this part, that's why I'm using this one. So omega square is pi square and y we have 0.2. So for calculation purpose, you may write pi square as 10. So it will be 10 multiplied by 0.2. That will be minus of 2 meter per second squared. Is it clear? Hiba, any doubt?
No, sir.
Okay, just write it down. Salman, done?
Yes, sir, done.
Okay. Next question, you'll be asked to define superposition of two SHM. Superposition of two SHMs. So first, what do you mean by superposition? You'll say addition of two SHM. Now, we may have two different types of SHM. Suppose y1 is equals to a times sine omega t, and y2 is equals to some b times sine omega t plus phi. So on adding, y equals to a times sine omega t plus b times sine omega t plus phi. In this part, we have same omega for this one and this one. It means angular frequency of these two terms is same. Next, we have same function sine and sine for these two parts. Only difference is their phase difference, that is phi. This part. So on adding this entire term, you will get y is equals to a times sine omega t plus delta. So how to calculate capital A using the above expression and delta using the above expression? Let me define you. We have already done vector in which I defined you how to calculate magnitude of resultant of any two vector. Similarly, this capital A will act as resultant or magnitude of resultant. So A is equals to, according to the concept of resultant of two vector, root under a square b square 2ab cos theta. So in this part, we can say a square b square and 2ab times cos phi. So this is how to calculate amplitude related to this part. Next, for calculation of delta, tan delta is equals to b times sine phi divided by a plus b cos phi. You may use this expression. This is related to tan beta, which was equals to b times sine theta by a plus b cos theta. Same as what we have done in vector chapter. Hamza, Is it clear?
Yes, sir.
This is the first amplitude of first wave, second amplitude, second part, and this is phase difference. I've just used these different terms for the calculation of amplitude and phase difference. In this part, I have taken omega and omega same for each different part. But suppose if you have equation like y is equals to sine omega times t sine 2 omega times t. So how to simplify it? You will say, since in this part we have different frequency or different angular velocity, omega and 2 omega. So on adding these two terms, you will get periodic but not SHM. But in left part, we have on adding two simple harmonic equation, we have got another simple harmonic motion as a result of it. So from this part, we can say two simple harmonic motion having same frequency will result into another simple harmonic motion. But if we have different frequency or different angular velocity for superimposition of two SHM, it will never be SHM. Khalid, is it clear?
Yes, sir.
Okay. So from this part, you will be asked,
Sir, by the way, could you again explain the last part?
this one.
Yes, sir.
In this part, we had omega and omega same angular velocity for both these two terms. So on adding, you will get resultant as another SHM having same angular velocity omega. So we can say superposition of two SHMs having same angular velocity leads to another SHM. But superposition of two SHM having different angular velocity will never be an SHM. Is it clear?
Yes, sir.
Okay, just 1 minute. We may write it like this. Superposition of two SHMs having same angular velocity will leads to another SHM with change in amplitude and phase. But superposition of two SHM having different frequency will never be an SHM. Now there will be a question related to this part. If y is equals to 3 times sine omega t plus 4 times cos omega t. So you will be asked to find amplitude of this particular equation. How to calculate amplitude for this part? Just say in this part, we have first function to be in sine and second is in cos. So to add any two SHM, first we need function to be in same term. So first we have to convert this particular cos in terms of sine. So we may write it as y is equals to 3 times sine of omega t plus 4. In place of cos, we may write it as sine of omega t plus pi by 2 using the identity I have just used in this part. This one. Hiba, is it clear?
Yes, sir.
Now in this expression, we have this term A, this term B, and this term phi. So using this formula of amplitude, may calculate the resultant amplitude for this entire part. Just write it down and try to find amplitude of this particular resultant part. Hiba, how much you have got amplitude for this part? Just put the formula. A is equals to A squared B squared 2AB cos phi. Salman, tell me the value of small a.
3, 9. So
So it will become 9. For B,
4, so it will become 16.
and 2 times A into B into cos phi, which is pi by 2. Cos of pi by 2 is Salman,
Minus 1 by 2.
pi by 2 is 90 degree and cos of 90 degree will be 0. So if you simplify it, this entire term will become 0. So 9 plus 16 will be 25. and root of it will be just 5. Iba, is it clear? Okay. Hamza, done?
Yes, sir. Done.
Any doubt?
No, sir.
So this is all about the first part of this chapter, that is displacement, velocity, and acceleration related to SHM. Next, we have to define energy of particle in uniform simple harmonic motion, as displacement is equals to a times sine omega t, velocity is equals to omega times a cos omega t in terms of time dependent, and in terms of displacement it will be root under a square minus y square. So first, potential energy. In work, energy, and power, I defined you potential energy stored in spring. Similarly, in this part, potential energy will be half k y squared. K is called spring constant, which is equals to m times omega squared times y squared. So in this part, k is m times omega squared. This is spring constant or force constant. I will derive this particular expression in next part of this particular chapter. Till now, just remember this part only. Now, in this expression, first, mean position when displacement will be 0. So potential energy of particle will be minimum, that is 0. But for extreme position, when displacement maximum, potential energy of particle will be maximum, that is half m omega square a square. Khalid, is it clear?
Yes, sir.
Again, we may define this potential energy in terms of time-dependent function. Potential energy is equals to half m omega square y square. In place of y, if you substitute a times sine omega t, so it will become half m omega square a square sine of omega into t. Using formula, sine square theta is equals to 1 minus cos 2 theta divided by 2. You may transform this relation as 1 by 4 m omega square a square bracket 1 minus cos 2 omega t is equals to potential energy in time dependent term. Now from this part, we can say displacement having angular velocity omega, but for potential energy, we have angular velocity twice omega. It means potential energy oscillate with twice angular velocity as that of displacement, or potential energy will have time period half of that of time period of displacement. Khalid, is it clear?
Yes, sir.
Okay, first write it down to this part. Hamza, done?
Yes, sir.
This is all about how to calculate potential energy with respect to given value related to this part. Next, suppose if you have to calculate kinetic energy. So kinetic energy is equals to half mv square, half m. V is omega times a minus y square in terms of displacement. So in this expression, first mean position when displacement is 0. So in this part, kinetic energy of particle will be maximum, that is half m omega square a square. But for extreme position, when displacement is maximum, kinetic energy will be minimum, that is 0. Again, we may define this kinetic energy in terms of time-dependent function. Kinetic energy is equals to half m v square, half m. If you put v is equals to omega times a cos omega t, so it will become omega square a square cos square omega t. Now we have to transform this square term into linear power. So according to the relation, cos square theta is equals to 1 plus cos 2 theta divided by 2. You may write 1 by 4 m omega square a square bracket 1 plus cos 2 times omega into t. Now again in this part we have angular velocity as twice omega. So we can say kinetic energy will oscillate with twice angular velocity as that of displacement or velocity. Or you can say it will have time period half as that of displacement. Khalid, any doubt? Now in last part, to get total energy. Total energy is sum of kinetic energy and potential energy. So if you put kinetic energy as half m omega squared bracket a squared minus y squared. In terms of potential energy, it will be half m omega squared y squared. Just expand this expression, you will get half m omega squared a squared minus half m omega squared y squared plus half m omega squared y squared. Now in this, we have this term is in negative and this term is in positive. Both are identical to one another, so they will cancel out. So you're left with total kinetic energy is equals to half m omega squared a squared. Total energy is equals to half m omega squared a squared, which is nothing but equals to maximum kinetic energy or equals to maximum potential energy, and will be always constant. Hiba, any doubt?
No, sir.
Okay, just write it down. Hamza, done?
Yes, sir.
So from this entire part, you'll be asked some different question. First, find displacement of particle at which kinetic energy equals to potential energy. So just equate kinetic energy and potential energy. So the formula of kinetic energy was half m omega squared bracket a square minus y square. And for potential energy, we have half m omega squared y squared. Just simplify it to find y. Try to solve. Hamza, you got any answer? Heba?
No, sir, I'm doing.
Just see, we have half m omega square common in both these two parts. So these two terms will get cancelled out. So you'll get a square minus y square is equals to y square. Move this y to right side. So you'll get a square is equals to 2 times of y square, or y square is equals to a square by 2. So on taking square root, you will get plus minus a by root 2. So just remember this particular part. At this displacement, kinetic energy and potential energy will be equal to each other. And also at this point, it will be half of total energy. Khalid, is it clear?
Yes, sir.
Again, similar question will be, find displacement of particle at which kinetic energy is 1/4 of total energy. Just use the formula of these two parts and simplify it for y. Try to solve using the above using the formula of kinetic energy and total energy. This part and this part will get cancelled out. So you're left with a square minus y square is equals to a square by 4. Move this part to left side and this y square to right side. So you'll get a square minus a square by 4 is equals to y square. Good, Khalid. Now take LCM of this part. So on taking LCM, it will be 4 minus 1. 3 divided by 4 times a square is equals to y square. So y will be root under this entire term. So it will be root 3 divided by 2 a plus and minus. So this will be your final result. Hamza, is it clear?
Yes, sir.
Okay, so let's stop here for today. I defined you whole different term related to this energy also. In next class, I will explain you graph of this entire part and relation of time period frequency related to all these different terms, that is displacement, velocity, acceleration, kinetic energy, potential energy, and total energy. Then we'll start with time period oscillation of different oscillating body. Any doubt from today's class?
No, sir.
Okay then, so let's stop here. Thank you.